Sorry, answer again.
Yes,
What is the problem? What is the problem, sir?
Can't you see the question on the screen?
Yes, sir.
So that is the problem.
That is the problem, sir. Okay, sir. Sir, can I explain, sir?
State space equation has been given to you, the output equation has been given to you, and the initial conditions are given to you. You are asked to find the output at t equal to 1 second.
Yes, sir. Can solve it, sir, the sum? Solve the sum. Solve it, sir.
Gangadhar, please turn off your, mute yourself, or else I would be forced to, remove you from the meeting. First of all, second thing is, I am giving time for the students to solve the question. I have given 3 minutes time for the students to solve the question. In between, you cannot ask me for the solution. Let others
Okay,
try if
sir.
you don't want to try.
Okay, sir. Right, sir.
Yes, the 3 minutes time that I have given is up. Anybody has come up with the answer yet till now? Anybody with the answer? Anubhav, what is your status? Anubhav? Okay, so I think nobody has done it. Anyways, let's see how to solve this sum. So the state space equation has been given to you. So let us rewrite these equations again. So if we rewrite this equation, so the state space equation has been given to you, and the equation is as shown in the screen. Okay, so one thing that you notice over here is yt is equal to x1t, right? So what we are interested in is to find the value of x1t, the value of the state x1t at time t equal to 1 second, and the initial conditions has been given to you. So the state space equation is written in the form x dot equal to ax plus bu, and the output equation is given as y equal to c into x. So comparing these two equations, you can get the matrix A, B and C. So what we end up getting is A as this matrix, that is 0, 1, 0, minus 2, which is a matrix of dimension 2 cross 2, and B, which is a column matrix of dimension 2 cross 1, having elements 0 and 1. C is a row matrix having elements 1, 0 of dimension 1 cross 2. So I have told you that, yt is equal to x1t. So we are interested only in the value of the state variable x1. Okay. Having said that, let us move how to do it, to see how to do it. So first, let us find the state transition matrix. So how to find state transition matrix has already been told to you in the previous class. So that is Si minus A whole inverse. So if I do this operation, the state transition matrix, the Laplace transform of the state transition matrix is this one. Now to find the value of the state at any instant t0 which is greater than 0, it is given by xt equal to phi t into x0 plus 0 to t equal to t0 phi t minus tau b into u tau d tau. Okay, so now you see this term over here is very familiar to us. It looks like convolution, right? So this is nothing but the convolution of phi and u. So if we move from time domain to s domain, then we know that in S domain the convolution becomes multiplication, so the mathematical rigor will go away. So let us just move to the Laplace domain by applying Laplace transform on the either side. So if we do that, what we have end up getting is xs is equal to phi s into x0, because x0 over here is constant. It is the initial condition vector that is given to us, and this term is the convolution term. So it is phi s b into us. So now we have, what you have to do is we have to find these two matrices, that is phi s into x0 and phi s into b into us. Let us do this operation and see what we get. So if we do this operation, what we end up getting is 1 by s and 0, and the other term has elements 1 by s square into s plus 1, 1 divided by s into s plus 2. So we end up getting xs as these two terms. Okay, so now I have already told you that we are only interested in x1s. We are not interested in the other variables, because in the question we are told that y1s is equal to x1s. So we are only interested to find x1s. So in order to find the value of x1 at time t equal to 1 second, we need to take inverse Laplace of this term, this 1 by s square into s plus 2 plus 1 by s. This term we need to take a Laplace inverse of it. So let us do it and see what the answer is. So what I have done is I have taken the inverse Laplace transform of this. So we get 1 plus t by 2 minus 1 by 4 plus 1 by 4 e to the power minus 2t into 1t. So this 1t is called a Heaviside step function. So the step function that you generally see in your books, which is actually represented by ut. So ut in control literature is actually input variable. Actually the Heaviside step function is represented by this 1 of t. Okay, so the next step is just to put t equal to 1 and find the answer. The answer would be 1.284. Okay, okay, so everybody got the answer? There is some doubt or something? Nobody is trying the sum?
Yes, sir. Hello.
Yes, Anubhav, yes, tell me. Yeah,
Yes, sir. How did you write zero in state response?
0 in state
The
response.
the integrated term time domain.
Yeah, yeah, this term you are talking about, right?
Yes, sir.
Yes. So how do I get this term you are talking about? Anubhav, what are you asking exactly? Do you want to know how to get this term? What are you trying to ask? Anubhav, hello? Anubhav?
Oh, sorry, sir. Hello, yes, sir.
Yes, yes. So what are you asking? How I am getting
Yes,
how I am
sir.
getting this?
Yes, sir. If you could explain it, it would be
Yeah.
better.
So in that case, you need to solve that solve for hope. Have you gone through that? How to solve a homogeneous differential equation?
Yes, sir.
So in that case, how do you do it? So you say the first step that we do is we need to find a general solution, right?
Yes, sir.
But how do we find a general solution? By putting input equal to 0,
Yes, sir.
right? So if you go for that, if you do solve the differential equation, you will get one term because of the initial conditions that they are having.
Yes,
if
sir.
if you remember e to the power minus 80 into x of 0, that is the initial condition, you can just write. I do not have a writing pad, or else I would have derived it. So the thing is, what you can do is you make in any differential equation, first make the input equal to 0, find the homogeneous solution, and you replace e to the power at as this phi t. You will find that what you will get is e to the power minus at into x0. So this phi t is nothing but e to the power at, where a is this matrix. A is this A matrix over here. A is this A matrix over here. Okay, are you getting my point, Anubhav?
Yes, sir. Yes, sir.
So this
You
term is
are
for the
saying
initial condition. And how am I getting this term? This term is due to the input that you are giving. So in solving differential equation, you would have found that there is one general solution and another with a particular integral we have come across with, particular integral, right? You have read about particular integral, how to solve?
Yes, sir. Yes, sir.
Right.
There are various methods to solve them.
Right. So this is nothing but so you see this term is associated with the initial condition of the system, and this term over here is associated with the input that you are giving. Okay, this is the convolution of phi t and xt. You understand what I am trying to say?
Yeah, the first term is because of the initial condition and the second one is because of the input.
Right, correct. So the simplest way to understand this thing is you write a differential equation, and a simple first order differential equation you write, and then find the solution for the initial condition. Take initial condition, say dx dt. You take initial condition equal to x0, and then write the equation. You replace e to the power minus at with phi t. Then you will get this relation. Easily you will get that relation. There is no difficulty in it. Any standard textbook you can consult. You will. This is the first step or the first thing that they would do in a state space chapter. If you go, this is the first step that they will show.
I just memorized that L inverse SI minus A inverse B into US.
No, you need to go through some textbook also. See those things. I understand that it is difficult to read textbook. Yes.
Sir, which book is best for the statistical analysis?
Yes. One more time. Who was it? And please, can you repeat what you asked?
No, sir, for reading the chapter statistical analysis, which book should we prefer?
So basically, I used to follow Ogata. So the Ogata and BC Kuo is a very good book for control systems. But which year are you in right now? I mean, are you pass out, or you are third year, fourth year? Which year are you in?
I am pass out.
Pass out, okay.
Why I want such book? They have simple language and the whole concept are covered.
Okay. Yeah, I mean, we actually assume that you have read all these things and then you are coming to the class, because we are not taking, we are not covering the theory part over here. We are just solving some. So I assume that you have read all these things in books. So you can go through BC Kuo or you can go through Ogata to understand what I have exactly done over there.
Okay, sir.
Okay. So okay, so let us move to, do you want any more clarification on this sum, or is it okay?
Okay, sir.
Okay. What about others? Anubhav has said. What about others? Gangadhar, you have understood? Gangadhar, I don't think he is trying the questions. I do not know. I mean, are you trying? Can you please tell me what your status is? Are you trying to solve the question, or you are not trying? You have given up? Not know. Anyways, what about others? Anybody else have tried to solve the question?
No, the statistical analysis is not covered very well.
Okay. Okay. So I am moving on to a different topic. Let's move on to circuit theory. Okay. Do you want me to give a simple sum? Let's do a simple sum first. Okay. So I would expect you to do this sum just by looking at it. Just 2 or 3 minutes I would give. 1 minute is enough for this sum with 3 materials, right? Question 31. So 1 minute time is enough for this sum. I am showing you. Okay, get this open. Okay, so this is the question. So you have been given a circuit and you are asked to find the voltage across the 6 ohm resistor at steady state, once the switch is closed. So I would expect everyone to do this sum very quickly. Let me give you
5 volts.
Yes.
5 volts.
Right, absolutely. So what is the voltage across the capacitor at steady state? What is the voltage across the capacitor at steady state?
It will be sir 10 volt.
At steady state it is 10 volt.
Not the final value condition.
At final value it is 10 volt.
Yes sir.
You are sure? At steady state you are saying there is 5 volt across this, and you are saying no current can flow through this. So how can this be 10 volt? If it is 10 volt, if it is, you are saying this 5 volt, and then if it is 10 volt across it, 5 volt, there will be current flowing through it, right? How it is 10 volt?
So it will act as open circuit at infinity. So we consider only three resistors, 2 and 6 and 3 in
Open
parallel.
circuit, that is a model. Open circuit, that we say that it is acting as open circuit because the current through the capacitor has died down. It doesn't mean, it doesn't mean that it is, as no current is flowing, we are saying it is acting like an open circuit. I am asking at steady state what will be the voltage across the capacitor?
5 volts, sir.
Correct,
5
absolutely.
volts.
5 volt, because see, it's very simple. So you see, if at this point you are saying it is 5 volt potential, so if no current flows through this, there is no voltage drop. If there is no voltage drop, then the voltage across this must be 5 volt. Correct.
Yes, sir.
Yes, sir.
Okay, these are very simple sum. Okay, so a bit, let me see next sum that is given to me. This time I will give you time. Okay, I will give you 3 minutes time to solve. Yeah, I will give you 3 minutes time to solve it and tell me what answer you are getting. So it is 7:21. I will be asking you at 7:24. It's already 7:24. You want one more minute? Okay, I'm giving you one more minute.
Sir, I think it's C, sir.
Okay, good. Right. Who was that? Who said it was C?
Sir, Ramtula, sir. Ramtula check.
Ramtula. Okay. Okay. Right. Okay. What about Nafkirti? Yes, Nafkirti, have you done the sum? Why? This is a network theory question. You said you are strong in machines and all. Try to solve questions, because or else this fear of not solving question will hamper you actually. So try to solve as many questions as you can. Okay, so it is already time. So time, I mean, you have already exceeded the time limit that I have given. Let's see what is the problem. So you have understood the question, right? The three phase voltage has been given to you. A line to line voltage has been given to you, that is 10 root 3, and the loads are given, that is 10 ohm, ZB is 20 angle 60, and ZC is asked to find out. So this is a classic example of unbalanced system. So ZA, ZB and ZC are not same. Okay, so what is the problem that we would face if ZA, ZB and ZC are not same? Anybody from the audience? What do you think would be the problem if ZA, ZB and ZC is not equal, or not equal? Yes,
Sir,
anybody?
circulating current, circulating current.
Circulating current. Where, what kind of circulating current are you talking about? Where will the current circulate?
Sir,
From the neutral.
unbalanced currents are drawn from the supply, sir.
Right, you are right. Unbalanced current will be drawn. Somebody wants to join. People who are joining late, try to join by 7 o'clock, or else in between I have to stop the presentation, and then you have to admit everyone. Anyways, so yeah, the current IA, IB and IC would be unbalanced. You are correct. So because of that, what problem are you going to face? So what is the problem if I draw unbalanced current? Anyone? What problem can we face if the currents are unbalanced?
So neutral current is not is going to be zero.
Absolutely, absolutely. So this question itself, gives you a very good example of oscillation of neutral. I hope if you have gone through machines, you have read about neutral oscillation when third harmonic current flows and all. But let's see what happens over here. Okay. So you see these 2 points. So this point is connected to, it is connected with where? To EA. This point is again connected to EB with a wire, and again this point is connected to ZC with a wire. So potential potential at these points are fixed. So I am representing each of these voltages by a phasor over here. Like the red voltage is the EA phasor, the green voltage is the EB phasor, and the blue voltage is the EC phasor. So you see the tips of this phasor is fixed to this point. So the potential of this is equal to potential of this. So the potential at these points, the green tip, the blue tip and the red tip are fixed. However, the current flowing through this are not balanced. As a result of which, what you can find is, the voltage drop in this A phase, in the A phase load may be higher, or it may be the other way around. So what would happen is, the voltage drop over here may be high, and the other two branches of the load will have a lesser voltage drop, and the neutral may shift. It may happen the other way around. It may happen that the blue the blue phasor is of greater length, the other two are of lesser length. So it depends on what load you are connecting, but this is what happens. The load gets shifted. So what we do is we connect this to this neutral point so that it remains fixed at that potential. Okay. So have you faced this problem in any power electronic circuit that you use? Anybody who has studied power electronics?
No, sir. Actually, neutral testing is not covered there.
No, I'm not talking about neutral, oscillating. This kind of problem you would be finding in power electronics too. I mean, maybe now you are in undergraduate stage, you haven't designed a buck converter. Maybe while you design a buck converter, you will be facing a bit of a problem. Let me, bring a picture of buck converter to show what I am trying to say.
Okay, sir.
Okay. Picture of buck converter. Let me just see. Okay, these are giving circuit diagram, right? Okay, let us look at this picture. You can see this picture, right?
Yes, sir.
Yes. So now to turn on and turn off this switch, what do you do? How do you turn on and turn off this switch?
So by using BJT,
This is a MOSFET. This is a MOSFET. So how do you turn on
MOSFET.
By
a
using
MOSFET?
gate pulses, sir.
Gate
Correct.
pulse.
Yes, correct. You need to have a gate pulse. So
Gate
this is
pulse.
the drain. So this is the drain. This is the source. You need to connect a, a gate driver which will give you positive pulse, right? Yes or no?
Sir.
Yes,
Yes,
sir.
sir.
Yes.
Voltage control device, sir.
Yes. So you need to connect a gate driver which can give you plus 15 volt or something, plus 10 volt or something, depending on what gate driver, what voltage your design is for. But with respect to whom? I am saying plus 10 volt. But with respect to whom do I need to provide this 10 volt? Anybody? With respect to whom are you giving this gate pulse?
Sir, maybe sir grounding or 0 volt potential.
No,
Great
you are
drain.
giving this with respect to V, with respect to the source terminal. You have to have a 10 volt with respect to the source terminal, right?
Okay, sir.
So VGS, how do you turn on? By turning on VGS, right?
By controlling VGS.
By controlling VGS. So you
Yes,
need
sir.
to apply a voltage, say suppose plus 10 volt you have to apply, or plus 5 volt, whatever voltage you are giving. You have to give it with respect to this potential, on which my cursor is right now. With respect to this potential, with respect to this point, you need to apply 10 volt over here or 15 volt, whatever voltage it is. You need to apply a positive pulse with respect to this point, with respect to this potential at this
Sir,
point. Yes.
sir, in a small signal model, the input supply is between gate to drain
Small signal
for
modeling.
MOSFET. So we apply voltage in between gate to drain and then current flows from source between source and drain.
Between? I am not getting you. Please, can you repeat?
The input voltage is between gate and drain,
The
and the
input
current.
voltage. That is the input voltage. But how to turn on the switch? You have to
So
turn it on, right?
okay, you are creating channel. Yes.
Yes. How do you create the channel? By turning this.
Between drain and source.
Yes. By applying a
Okay.
positive voltage across VGS. You have to apply a positive VGS at the gate terminal. Then only the switch S will be turning on, right?
Yes.
So now see, you are saying you need to apply a 10 volt with respect to potential at this point. But is the potential at this point known to you? Is it known to you? Who I mean, who was that? Who was answer? Who was saying? Yes. Anubhav or whoever was saying. Is this potential known to you? This point, potential at this point, is it known to you?
No, sir.
Why it is not known to
No,
you?
sir. Because additional voltage is added up, sir.
No. Why additional voltage? You see, you have a inductor over here, you have a diode over here. This point, at this point, you have a voltage strip element. The voltage across the capacitor will not change significantly, and you have a voltage strip element. So you can say that this is at a fixed potential. There is a current strip element over here. There is a current strip element over here, and there is a diode. And you don't know whether the diode is conducting or is not conducting, but you have to apply this positive voltage or negative voltage to turn on or turn off the switch. How do you do it then? See, in the textbooks you just find only this circuit. You would never bother about how to turn this on and off. But these are the things that will come up when you design this buck converter. This potential is as a floating potential. When the diode is conducting, the potential of this point is 0. When the diode is not conducting, the potential of this point is V in. If we neglect this voltage drop across this, if it is conducting. So this potential is, this point is at a floating potential. So how do you turn on? So does that mean we cannot turn on the switch? What is happening over here?
Sir, whether it should be approximate range, some kind of range of voltage which can float here.
Any other solution you can think of? Any other solution by which you can overcome this entire problem? Anybody from the audience? Anybody? Ramtula, if you can think of, you can just suggest. You can help your friend out. Yes, Ramtula.
Sir, can you repeat the question, sir?
I am saying that this point is at a floating potential. Therefore,
Yes, sir.
so say suppose this point is at 5 volt. Okay, say assume that this is at a 5 volt potential. Now you are saying
Yes,
I am
sir.
applying you are applying some 10 volt over here with respect to ground. So the
Yes, sir.
voltage across this becomes 10 minus 5, that is 5 volt. So instead of applying
Yes,
10
sir.
volt, you are applying 5 volt across these terminals. You are getting my
Yes,
point.
sir.
Say at point 1 you write it is 5 volt, and at this point, at the
Yes,
gate
sir.
point, right, it is at 10 volt. So what is the potential you are applying across VGS?
So that is voltage drop subtracted from VN, sir.
The voltage drop between this gate and source, that is, I have told the gate is at 10 volt and this point 1 is at 5 volt. What is VGS? Gate to source, what is the voltage across this?
5 volts, sir.
5 volts, sir.
5 volt, right?
5 volts, sir.
Yeah,
EG minus EF.
Yes,
right,
sir.
correct. So it is 10 volt and 5 volt. So you are applying 5 volt, whereas you want to apply 10 volt. So you see,
Yes, sir.
so the proper turning on of the switch would not occur. So what remedy can you take to avoid this problem altogether? Very simple strategy I will tell you. Very simple way of doing it.
Is it open?
Open what? What would I open? The switch. If I open the switch, then there is nothing.
No, we connect op-amp. No.
Where will you connect op-amp? That is also going to give you plus
In
5
fan.
or plus 15 or
Sir, external supply so that we make the potential constant at this moment, and after that moving.
any other solution you can think of. The external supply, those are very bad solutions you are thinking of. There is a very simple solution. You can see it is just before your eyes. You can just, okay, so forget about it. So see, if you place the switch, say this is, the top rail I am calling it as positive rail, the negative rail I am calling it as negative rail. Okay, so if I put this switch instead of on the forward path, if I put it over here, will the problem be solved? Yes, Anubhav or Ramtula, whoever is interacting.
Sir, then it will become short circuit, no?
No, instead of
Potential will be same.
putting it over here, I am putting it over here.
Means MOSFET will change from down up to down position.
Yes, instead of putting on the positive rail, I am putting the same MOSFET, invert the MOSFET and put it on the negative rail.
And how
Okay,
did the converter works after that?
Yes.
How did our converter work?
Yes, similar way. So if I put just a simple switch over here, and if you replace this switch with another switch over here, So will that be different? They are in series only. So what is the difference in it? Same operation.
For on time and off time.
Yeah, it would be same. Uh, so I do not think there is any picture of this sort over here. I do not think there is any picture. Let us just look at this picture. So instead of putting switch over here, I am putting it on the negative rail. The same switch, I am shorting this path and I am putting the switch over here. Are you
Yes,
getting?
sir.
So will there be any difference?
Yes, sir. No, sir.
So, but it is solving a very critical problem. Do you know what? Do you understand what problem it is solving?
Yes, sir. Floating voltage.
Now what happens? You see. So if you place the switch over here, the source terminal the source terminal will be at this point. The source terminal will be at this point, and the drain terminal will be at this point. Current will be flowing in this direction. So now you have fixed the source at zero potential. Do you understand?
Yes, sir.
Are you seeing what I am trying to say? You draw the
Yes,
circuit
sir.
on your
Yes,
paper if you have a paper or pen with you. Draw the circuit. You short this path. You don't put a switch in this path. You put a switch in this part. Okay? So instead of switch, you draw the MOSFET at this point and mark the drain, source, and the gate terminals. You will understand the source now is connected to the negative terminal of the source. The source terminal of the MOSFET is now connected to the negative terminal of the voltage source. So now your source terminal is at a fixed potential, which is zero potential. Now you can apply a 10 volt or 15 volt, and you can get proper operation of the MOSFET. Whatever voltage you want, you can apply to the gate and you can turn it on.
But there is a diode, so there is a different condition for starting conducting of the diode. So condition will change now.
Why would I do not understand why you are saying there will be any change. So if you are having this problem, then I have to draw this or do something like that. I don't have anything to draw. That is the problem. Then you have to give me a minute. Okay, give me a minute. I will just open up some Inkspace and I will just show. Where is this NPTEL stuff? Or it will take time. Yes, tell me. Yeah.
Again, positively, if the reference voltage is negative, zero, but basically the voltage is minus Vs. VGS equal to VG minus VGS equal to Vn of minus is goes to plus. I mean, we get higher voltage.
No. Why? See, you have to see. So this potential, so the negative potential you consider as ground, 0 volt. Okay. This potential is at 0 volt.
Okay,
You
but
are
the
measuring everything with respect to this
okay,
potential,
okay.
right? So this is what is ground? What do you mean by ground?
Ground is zero potential.
Ground is the potential with reference
Yes,
to which I am measuring everything else.
yes,
Okay,
yes.
if I am saying that this is ground, that means with respect to this I am measuring everything. Okay, this is my reference point. That means.
Okay,
So if I place it over here, if I place a switch over here, then the drain terminal will be over here, the source terminal will be over here, and the gate terminal will be over here. So now these are zero potential,
okay,
and you are applying 10 volt at this potential. So you are going to get
okay.
the confusion that we had in the previous case, that whether we are actually applying 10 volt or not, that is now clear. See, this point is fixed at zero potential now, so I am applying absolutely 10 volt at the gate. Are you getting my point? Are you getting my
Okay.
point? Or do you want me
Yes,
to
sir.
draw the entire circuit? If you want me to draw, then you have to wait. This will take time. This I do not know why this takes a lot of time.
And that means the duration of conducting of diode is now controlling by different way.
duration, I mean, yeah, I mean, that is, whenever you turn off the switch, the diode will automatically conduct. Okay, or this is a boost converter I'm showing. Anyways, give me a bit of a time. Okay, just give me a bit of a time because I need to draw the circuit then. Okay.
Sir, I think that like that one way, if we in the original position, if we apply the gate pulse to the MOSFET, and that is suppose it is during turn on time,
Hmm. Yes.
and now if we apply the maybe change the position of the MOSFET and then apply the VGS voltage, that means it will become the then off period time. Like,
Yes. What are, I mean, yeah, I mean, what are you saying? Like, just give me a minute. Let me just draw the circuit. The same thing. Okay. Oh, this takes a lot of time. So in the meantime, okay, bro. In the meantime, I have already solved the question. So in meanwhile, while I draw the circuit, can you please explain what you are doing in the sum? Whoever has done the sum, you just explain to your friends how you are doing the sum. Let me draw the circuit because or else there will be wastage of time. Explain what you are doing to your friends, and I will be coming up with the thing that I'm saying. Hello Ramtula, can you just explain what you have done in the sum? That what you have done, can you just please explain in the time in meantime while I do this all these things.
You were drawing circuit, sir.
The gate question that I just gave you, can you please explain it to your friends?
Yes, sir.
Please explain it to friends because I need time to draw the circuit. Just give me some time.
Actually, I found phase voltage that is VA equal to VL by root 3. I got 100 volt at zero reference. That is VA equal to 100 at angle 0 degrees. Next, VB equal to 100 at angle minus 150 degree. VC equal to 100 at angle minus 240 degree. Now I have to find IA value. IA equal to VA by ZA. That is IA equal to 100 at angle 0 by 10 at angle 0. ZA is given just 10 ohms. That means 10 at angle. Then IA will be 10 amps. That is IA equal to 10 at angle 0 degrees. Next I have to find IB value. Now I use IB by ZB. Here ZB equal to, given that ZB equal to 20 at angle 60 degrees. So that IB will be 100 at angle minus 25. ZB equal to 20 at angle 60. Therefore, IB will be 5 at angle minus 60. Now, that means IA is no reference value. That means at angle 0 degrees. VA, IA are in phase. Therefore, IA 10 amps will be flow through phase B and phase C. That means uh, here we can say that 10 ohms, 10 amps current will be flow through phase A and phase B with the magnitude of
Okay,
5 and
okay,
angle will be
Ramtula, thank you very much. Thank you
angle
very
will
much
be
for
different.
explaining this sum. Just give me a minute. I will be just telling them what I was trying to say. Okay, so so look at the circuit. So do you find any difference between these two? Is there any difference? Yeah, Anubhav, you are saying
Yes,
the
sir.
operation.
Full of MOSFET.
Yes, yes.
These are not in
The
any way.
position of MOSFET is changes.
A position, yeah, but is this going to affect the operation in any way? Is it going to affect the operation in any way?
No, sir.
Sir.
No, sir, nothing will change here.
Correct. But what advantage are you getting? You see, this terminal. So this terminal was the source terminal. This was the drain terminal. Now I have inverted this. So now this would be your source terminal and this is your drain terminal. Now see, your source terminal is now fixed at this point. Over here, your source terminal was not fixed. You do not know whether the diode is conducting or not. But now it is fixed to this potential. So if I consider this as 0 volt, I am measuring this, I have considered to my reference voltage point. So if this ground potential, so now whatever voltage you apply, 10 volt maybe you are applying, so you are applying, without any confusion you can say that there is 10 volt across this. However, at this point you cannot, I mean, you cannot, what should I say, confidently say that this is 10 volt, because you do not know what potential this point is at. This point may be at 5 volt, it may be at any other potential, you never know. So in that case, I mean, proper turn on of MOSFET would be difficult. Are you getting my point, everyone?
Yes, sir.
So this is actually, you have to understand the gate driver part of the switch that you are doing, but I do not think these things are taught anywhere. You are only taught this power circuitry. Anyways, you would be learning maybe while you do masters or whenever you want to. Okay, let me go back to the sum which I was saying. Okay. So the neutral oscillation point I was saying. So this neutral oscillation phenomena you have also read about in transformers, where when the third harmonic current flows and all, and there may be a possibility of neutral oscillation. So I have told you the currents are unbalanced, the voltage drop across the load may be different, and you may observe this phenomena. So now question has asked what load you should connect so that the potential at n and n dash is same. The person was having confusion about zero potential. See, this neutral is, say, if I say the neutral is my reference point, I am measuring all voltages with respect to neutral, then we consider this potential to be zero. So if I consider this potential to be zero, because of the unequal voltage drop over here, this potential is no longer at zero, it is moving away. Okay, so this is moving at a negative potential maybe, or whatever. If this point is at zero potential, you are moving at a negative potential. Okay, with respect to this point you may have a different potential over here. So that is what I am saying when I am saying neutral point or ground point. Okay, so now let us see how to solve this sum. So EA, EB and EC are given to you, ZA and ZB are given to you.
Sir, why this break?
Yes, yes.
There is interruption in the voice.
Yes. You cannot hear me. What is the problem, Ashwini? Hello?
Sir, your voice is clear. I think he has connection problems.
Okay, okay,
And the
okay.
voice.
Okay. So now, so let us forget about this sum as of now. So if IA, IB and IC is unknown to me, EA, EB and EC are known to me, and we are told that ZA, ZB and ZC are known to me. So EA, EB, EC are known to me, ZA, ZB and ZC are known to me. We are asked to find IA, IB, IC. We are told that ZA, ZB and ZC would be unbalanced. How do you do that? Can anybody in the audience say how would you do that? If IA, IB, IC are unknown to us, EA, EB and EC are balanced source, ZA, ZB and ZC are unbalanced loads. How would you approach the sum in such a case? Anybody from the audience, tell me, how are you going to do the sum? Hello? Anybody? Hello? Well, in such a case, when the loads are unbalanced and your IA, IB and IC, you need to find out. What you can do is you need to write the KVL equations for all the three loops. Okay, all the three loops you have to write the KVL equations, and then you have to find IA, IB, IC. That would be a very tedious process. And the other method of doing it is finding the symmetrical components of IA, IB and IC by drawing the the positive sequence, negative sequence and zero sequence current. In that case it would be a very tedious sum. So to make our life easy, in the question it is told that we need to make n and n dash to be at same potential. So both this would be at zero potential. So if we are told that both n and n dash are at same potential, then we can claim that the voltage across ZA is EA and the voltage across ZB would be EB, voltage across ZC would be EC. Correct?
Yes, sir.
Clear,
Right?
sir.
So that is happening only because we have
Okay.
assumed we are asked in the question that at what load these two potential will be same. So in such a case we can say that the voltage across ZA is EA, voltage across ZB is EB, voltage across ZC is EC. So you need to find then IA, by this simple Ohm's law that you do, EA divided by ZA, you get 10 angle 0 ampere. You find IB, which is EB divided by ZB, which is minus of 5 amperes. Now by KCL, if you look at it, IA, IB and IC are all pointed towards n dash. So IA plus IB plus IC has to be equal to 0 according to KCL. So let us do that. So now from here we can find IC, which comes out to be again minus 5 ampere. So now to find ZC, what we do is EC divided by IC, that is 20 angle minus 60, and the correct option is C. Is that okay? Anybody has any doubt with the solution?
No, sir.
Sir, once more, soft currents are equal to 0 ohms.
So IA is flowing along this direction, IB is flowing along this direction, IC is flowing along this direction. All the three currents I have assumed to be in this direction. That is moving in n dash point. So what does KCL say? If there is a node and all the points are connected in the same are directed in the same direction, then the summation of all those currents must be equal to 0. That is
Okay,
what I
sir.
have. Okay, right? Very few are answering questions. I do not know whether you are either at all trying or not. I am just I am just hoping that you are trying, because that do good for you. Anyways, do you want to solve another sum? It is already 8. So do you want to solve another, or what do you want, or do you want me to stop?
No, sir. In your next slide.
You want to solve another sum? Okay, I will give you another sum then. Okay. Okay. And I would, this is a good question. I love this question. So let's see. I love this question. Let us see how you approach the sum. I will ask you about the approach. Let's see. So this is the sum. Anybody who can say it? is based on your class 12 knowledge. I do not expect any engineering knowledge to solve this sum.
Sir, there is a two variable is given here.
Two variable is given, right? So what do you think would be what do you think would be the solution? Acha, forget about the solution. Tell me what this curve looks like. T minus 1 into T minus 2.
It will be parabola.
Correct. Absolutely, it is parabola. And what is this? E to the power T.
Rising steadily,
Exponential, right?
steadily increasing.
Yeah, right. So I have put this in this file. Okay. So you see, you are multiplying these two curves. So this is, the parabola intersecting points if you find, it is 1 and it is 2. So these are the roots of the equation, right? So at this point the function will be 0. So at 1 and 2 it will be 0. And when t equal to 0, what do you have? Minus 1 into minus 2, that is 2. So it is intersecting the y-axis at 2. It is intersecting the x-axis at 1 and 2. So the blue curve that you see is the parabola we are talking about. And the orange curve that you see is the e to the power t, or the exponential term. Now what do you need to do? You have been, multiplication of these two curves have been asked. So this is greater than 1. You are multiplying two quantities which are greater than 1. It will be slightly higher than this. It will be going to 0 over here, and again from here it will, it will again be 0 over here, and then again it will be sharply rising because there is an exponential term which is very sharply rising. So this will go up very sharply. So now tell me what would happen. You have been told that you have been asked to find the area under this pink curve, right? So integration from 0 to x means it is the area under this pink curve, while x may be anything. So for what value of x do you think that the area is going to decrease? That is what the
1
question
to
is
2.
asking. Yeah.
Between 1 to 2.
Absolutely. So see, so I am doing this. Say I want to find this area. So x is between 0 and 1. So what I see is it is positive area. Again, if I put x between this 0.5 to 1, what we are getting is again positive area. So area under the curve is actually increasing. Now if it is more than 1, if it is between 1 and 2, what is going to happen? Let me draw the curve over here so that you don't have a problem. Okay. So now what happens is the area becomes negative. So this area would be subtracted from this area. So when x is between 1 and 2, we start subtracting the area from the previously calculated area. So the net area under the curve keeps on decreasing. So the answer should be, the x should be from 1 to 2. Did you get the question? This is a very good question. I like this question.
Clear, sir.
Okay, then it is already 8:06. It's time for me to have food.
Sir.
Yes.
Sir. How did you say that t minus 1 into t minus 2 is parabola?
What is that picture I have got? Okay. So the x-axis I have taken t. Okay. So when and y-axis I have taken any function. So when t minus 1, when t equal to 0, what is the value of the function?
Minus 1.
When t equal to 0,
Okay, sir. 2, sir.
2, right? And when t equal to 1,
When t equal to 0, sir.
t equal to 2.
Okay, sir. By putting the values you said, okay.
No,
But how
not,
you said
I am not
directly?
saying it is the parabola by putting the values. Whether it is parabola or not, it is from your class 12 knowledge. So it is a quadratic equation. What is the equation of a
Yes, sir. Quadratic equation. T
Yeah.
square minus 3t plus 2.
Correct. That is from your class 12 knowledge. So that is from your school knowledge. I am saying that this is a equation of parabola which is intersecting at this point, and this point.
Okay.
Okay, so should I close the session? What should I do? Because my mess time has started. I would miss my food then.
Sir, almost time has start.
Okay, okay, then let's leave. Let's have food then. Enjoy your weekends. We will meet again on Friday. Okay, we will be
Okay,
doing
thank you,
control
sir.
systems again.
Okay, sir. Thank you, sir.
Okay, thank you.
Thank you, sir.